Hello, Algebra 2 students. This is Mr. Bear, and I'm going to be teaching you virtually how to do 8.2 equations of exponentials, okay? I promise you this is going to be a pretty quick video, but please remember you can pause and rewind as needed, okay? So your teacher should have already gone over the answers to the bell work with you, but if they did not, the correct answer for this first one should have been x squared plus 4, x plus 2, and x minus 2. Second one, the answer should have been 4. Okay. On the next one, the correct answer should have been graph D. On the last one, the vertex is 4, negative 4. The parabola opens up, has a standard width, and the y-intercept is that c value of 12. Okay. Now, let's look at today's lesson. Today's lesson is about being able to identify parts of an exponential equation so that we can write them. Okay, so make sure you're taking notes in your notes packet. Okay, so you've already torn off your bell work and now you are working on the notes. I promise I'm going to make this go quickly. I'll fast forward through the whiteboard problems and just focus on what do you need to know how to do. Pretty easy lesson. All right. First thing you need to know is that exponential functions look like the form y equals a times b to the x. Your a value is your y-intercept, which is your starting value. That'll make more sense tomorrow when we talk about modeling with exponential functions. Your b value is your growth or decay factor. If your b is greater than 1, it'll grow. And it'll decay if b is between 0 and 1. Okay? The way to remember that, growth occurs when you make numbers bigger. So if you multiply by 2 or 3 or 4 or anything bigger than 1, that's going to make the function grow. Decay, think of that as a fraction of something. So like if I take something and make it half the size or a third of the size or a fourth of the size, it gets smaller. That's why your b is between 0 and 1. All right, so let's do a few examples. Y equals 2 times 0.5 to the x. Well, my a is the 2. My b is the 0.5. Because my b value is between 0 and 1, it'll decay. Next example, I give you the a is 0.75 and my b is 2, so I'm going to put those into my equation. Y equals 0.75 times 2 to the power of x. Make sure that you're writing that x as an exponent. Okay, this would represent growth because our b is 2, which is bigger than 1. Okay. You could try to pause the video here and see if you could do the next 2 rows in the same way. All right. But the answers are a is 2, b is 3. Because our b is 3, it's going to be growth. Last row, we'd have y equals 4 times 0.25 to the x. Because my b is 0.25, we'll say this is decay. All right. Now, what if I'm given a table of values and I need to write the equation? Well, we start by finding our a value. A value is your starting value. It occurs when x equals 0. So I'm going to look in my chart and I see that x equals 2 when y equals 2 when my x is 0. So my a is 2. Okay. For my b, I'm going to see how the outputs change. All right, so we're looking for what is it that we're multiplying by. On this one, to go from 2 to 4, multiplied by 2. From 4 to 8, multiplied by 2, and so on and so forth. Okay, so my b is also 2. So my equation, remember, it goes y equals a times b to the x. So in this case, it's 2 times 2 to the x. On the next one, for my a value this time, I see that when x is 0, my y is 27. my b value. Now, when you look at the chart here, you're going to notice that the values are decaying. You might be thinking divide by 3, but when you divide by 3, that is the same as multiplying by 1/3. Okay, so think of it like you took a candy bar and you split it into 3 equal pieces. You divided it into 3 equal pieces, so each person gets 1/3 of the candy bar. All right, so we need to be thinking multiplication here. So we're going to multiply by 1/3, okay? All right, so my b is 1/3. So my equation is a, which is 27, times 1/3 to the power of x, okay? On the last one, ignore this last row. I was kind of playing around a little bit, but on this one, your a is going to be 1. Your b, multiplying by 4 each time, okay? Since we're multiplying by 4, that's our b. So we have 1 times 4 to the x. You could rewrite this so that that 1 in the front isn't there. So you might also see this as y equals 4 to the x. Either one is fine, okay? All right, now what if I have a graph? Well, if I have a graph, if I'm going to make my equation for this, I'm going to make a table to help me graph this. So I'm going to start with this first point right here, which is the ordered pair 0, 1. This next point is going to be the ordered pair 1, 2. And this point up here is going to be the point 2, 4. And when I have it written like this, I can go ahead and apply what I was just doing. My a is going to be 1. My b, well, I'm multiplying by 2 each time. So my b is 2. So 1 times 2 to the x, or simply y equals 2 to the x. Either one is fine. Okay? All right, next one. On this one here, I could see that this point, I'm going to do my xy table over here this time. That ordered pair is 0, 4. This next point is 1, 2. This point here is 2, 1. When I'm looking at this, I can see my a is 4. My b, I am dividing by 2 this time, but remember, we don't want to say divide by 2. We want to say times a half. Okay? So my b is a half. So my equation is 4 times 1/2 to the power of x. Next one here, this time we have some negative x values, and that's okay. It is okay if that happens, okay? So this one over here, this is negative 2, 4. This next point is negative 1, 2. This next point is 0, 1. And I've got enough now that I can make my equation. But notice this time the 0 is with the 1, but it's not the first thing that was written. But our a is still 1. And our b, notice this time, just like in the last one, we're going from 4 to 2 to 1. So we're going to have times a half. So you might have this as 1 times a half to the x, or simply y equals 1/2 to the x. Okay. Last idea here, how do we graph these, okay? So when we graph these, what I'm going to do, I'm going to teach you a little trick here. If your b is greater than 1, use positive x values, okay? Now, I'm going to start with where x is 0 because we know our output for our starting value is 3. So we know 0, 3 has to be a point on the graph. So I plot that on the x-axis, or sorry, the y-axis. Because my growth factor is 2, which is greater than 1, I'm going to use positive x values. So I'm going to come up with a couple of positive x values. Okay, so for this one, when my x is 1, I have 3 times 2 to the first, which is 3 times 2, which is 6. So 1, 6. That's this point here. And then when x is 2, I have 3 times 2 squared, which is the same as 3 times 4, which is 12. So when x is 2, I actually end up off the graph. Sorry about that. And so your graph will look something like this, okay? It should be growing because our b was positive, or not just positive, but it was greater than 1. Okay, let's try another example, okay? For this one, we have 2 times 1/2 to the x. So I know I'm going to have 0, 2, because remember your a is that value. Plot that on my graph. But this time, if your b is between 0 and 1, such as this 1/2 is, use negative x values, okay? So I'm going to use -1 and -2. Why am I doing that? Because if I plug this in, I have 2 times 1/2 to the -1. You may remember that a negative exponent just causes your fraction here to flip-flop, which will make that 2 to the +1. And that'll give me 2 times 2, which is 4. So I'll have -1, 4 on my graph. Okay? And then I'm going to do the same thing with x is -2. So I have 2 times 1/2 to the -2. Remember, the negative exponent flips the fraction upside down to make that 2 squared. That makes this 2 times 4, which is 8. So I'll have -2, 8. That will be this point here. And now we can graph it. Okay? All right. So now what I'd like for you to do is work on your skill check. And then when you're done, you'll work on 8.2 Delta Math. Now, I do want to point out one thing just real quick with regards to your skill check. When you are asked to graph the first one, you're going to see a grid where you only see 5 boxes that go in either direction. And you're graphing the function y equals 3 times, I think it's 3 times 2 to the x, possibly. Or no, I don't remember what the equation is, but the only thing that I want to say about this is on your y-axis, just count these by 3s, okay? I can't remember exactly what the problem is right now, but if you just count your y-axis by 3s, you'll be able to fit the points, because I think you need to be able to plot this point and then 1, 15, and your graph should look something like that when you graph it. So this is on that skill check when you're doing that, okay? All right, if you have questions, let me know. I'll be back on Friday, so hopefully I'll be able to answer any questions that you might have had.